Hello and welcome again to another Physical Sciences 3 lecture. This one we're starting energy. So we looked at work last time and we can define energy as the energy of a body determines its ability to do work. Okay. Since energy is measured in terms of the work a body can do, energy has the same units as work. Okay. We kind of saw that last time, that work has the same units of energy and they are measured in joules. So like work, energy is a scalar quantity, meaning we don't have to worry about what direction energy is going in. The energy of a body is determined by its mass, okay, is dependent on its mass, and either its position or the velocity with which it has, okay. So if we're worried about position, we're calling that potential energy, and velocity, if an object has velocity, then it has kinetic energy. And we're going to look at those in more detail. We have a list here of some of the types of energy, so gravitational potential energy, kinetic energy, elastic potential, heat, nuclear, light, electromagnetic radiation, sound, chemical potential, and electrical, and we'll have a look at some of them in more detail. First of all, we're going to look at potential energy. So this is the energy of an object due to its position or elevation, so this is often called gravitational potential energy. Potential energy. So if you lift something up above your head, you're not going to want to drop it because it has some potential energy, and if you drop it, it's going to convert that object into kinetic energy. It's going to start moving, and then it's going to hurt your head if you drop it on top of your head. So that's a form of potential energy, so when we lift something up. And if we look at the formula here, work is equal to force times displacement. Okay, we can substitute mass times gravity into our force, and for displacement we can say that's height, and work is equal to the change in energy. So that means that our potential energy here is equal to mass times gravity times height. Okay, so we can do that. We've got a little note here about there are many forms of energy, kind of similar to what we're talking about up here in our notes, and there's a note here that heat is a very important form of energy, and it's when there is friction, kinetic energy is being converted into heat energy. So that's just a side note there under potential energy. All right, so we just derived the equation for potential energy. It's equal to mass times gravity times height. Another common form of energy is kinetic energy. Okay, so this is the energy of a moving object and is dependent on both the mass of the object and its velocity, so how fast is it going. Similarly to potential energy, the amount of energy is a moving object possesses equal to the amount of work done accelerating the object to its potential. Okay, so I guess similarly to potential, so potential energies depend on the height at which the object is. This is dependent on how fast it is going. And this is the energy for kinetic energy. So Ek is equal to half times mass times velocity squared. So make sure you are squaring that velocity, is a common mistake. And there's a bit of an algebra challenge here to derive this formula. So if you again start with work is equal to force times displacement, and you substitute F equals ma into there, and you also use this equation of motion, you should be able to get to our kinetic energy equation. Just you'll have to assume, I'll give you a hint, assume U is equal to 0 if you want to go through that little algebra challenge, feel free. Okay, otherwise you can just remember that Ek is equal to half mass times velocity squared, and that'll get you through this course. You won't be asked to derive it. So, an example we have here, find the change in potential energy, the EP, when a 15 kilogram mass is lifted through a height of 1.5 meters. Okay, so EP is equal to mass times gravity times height, which is equal to 15 kilograms times by 9.81. So that's our acceleration due to gravity times by 1.5 meters. And let's just whack that into our calculator, and we'll get 15 times 9.81 times by 1.5, and that will be equal to 200, I'm going to go to three significant figures, 221 joules. Okay, and that's the three significant figures. 221 joules, okay. What is the kinetic energy of, so we've got two kinetic energy problems here. What is the kinetic energy of a 100 kilogram cyclist travelling at 22 meters per second eastwards? So EK is equal to a half times by 100 times by 22 meters per second squared. And if we put that into our calculator, we get, we're going to write a half as 0.5 times 100, or you could just work out that half of 100 is 50, times by 22 to the power of 2. And we get 24,200 joules. That's equal to 24.2 kilojoules. Often will be, you'll see it written as kilojoules, but you shouldn't be marked down either way for writing it joules or kilojoules. An electron of mass 9.1 times 10 to the negative 31 kilograms, moving at 2.0 times 10 to the 7 meters per second. Okay, so it's going very, very fast. You might want to say that, remember that the speed of light is 3.0 times 10 to the 8, so anything getting up towards those speeds is very, very quick. We use the same formula again, 9.1 times 10 to the negative 31 times by 2.0 times 10 to the 7. And let's put that into our calculator. So we're going to have 0.5 again, times by, I'm going to put in brackets, 9.1 times by 10 to the negative, I'm going to put these in brackets too because I'm not sure how it works with this calculator, negative 31, not sure how much they like negative numbers in indices. So we've got 9.1 times 10 to negative 31, and I've got the double brackets. Now we need 2.0 times by 10 to the power of 7. Just the single brackets this time. So we get 9.1, which makes sense, 9.1 times 10. Okay, so this might be the first time you've seen this little, you might see this in your calculator, little e, that means times 10 too. 10 to the negative 24. So, let's say in calculator, we saw that as, calculator, as 9.1 e, negative 24. Okay, and that means the same thing. So e, oops, oh gosh, e is equal to times 10 to the power of, okay, so e minus 24, maybe I'm labouring this, is equal to 10 to negative 24. If you come across that in your calculator, that's what it means. Okie doke. Alright, so we'll leave those ones. We'll do some more examples next time on energy transfer.